You saw me process the Dark Shark Nebula in PixInsight and you wanted a Siril version. Well, in this video, I'm going to give you exactly what you asked for, and we're going to use processes found in Siril, as well as scripts that are within Siril to get this resulting image of the Dark Shark Nebula. The PixInsight version had scripts and the software itself cost hundreds of dollars to get something really nice. And in Siril, we're only going to be using scripts that are free, although I'll mention Scicon that has models that you can download that give you better results. I am not going to use those in this video just because I want to keep everything at $0. And we'll go through the entire process step by step. But a couple of things before we get started. First, I'll admit that I'm way better at processing images in PixInsight than I am in Siril. So the resulting images may not look the same, but I'm hoping to teach you concepts and how the workflow should go, or the workflow that I follow in order to process dark nebulae in this software. And my final PixInsight version also took about 10 hours to do. That's because I spent a lot of time on it because that resulting image is actually going to be printed for an art show. The version you see in Siril took about 30 minutes from start to finish. Second, a huge shout out to Rich from Deep Space Astro for coming out with a very timely script. His script launcher script that works as a really nice workflow tracking list is very similar to the PixInsight process list that I shared with people. So in this video, at the end of this video, in the description, you'll also find a JSON file that you can import into your script launcher script and follow along. And third, if you don't already have dark nebulae data to work with, don't worry, I'll be sharing my stacked but unprocessed version of the Dark Shark Nebula in FITS format in the download link below. Patrons on Patreon can get it from that platform for free, but everyone else, including the public, you can get it from the Buy Me a Coffee link down below. It's absolutely free. You do not have to pay for this data. It's just that it lets me track how many people are downloading it. Totally optional to download. You don't have to download it, but if you do, and you do share this with others on the internet, I would greatly appreciate it if you would share credit. Now, the data itself isn't the best data, but it is clean data and it is pretty hard to acquire. I live in a Bortle 8 zone, so I went to a Bortle 3 zone in southern Vermont last summer to take 82 minutes of the Dark Shark Nebula. That's not a lot of integration time, and you'll see this when you're processing because the noise, the signal to noise ratio is not as good as I would hope. I planned for several hours of imaging, but the weather had other plans. Now let's get to the demo. Right, I'm in Siril 1.4.2. I have an empty working directory set, almost empty. I have a couple of V1 and V2 folders in there from my earlier runs. And the first thing I'm going to do is run a new script that Deep Space Astro created called Script Launcher. So this handy script will let me guide you through this whole process because I can put everything in order that I'm doing instead of putting it in a PowerPoint slide like I usually do. And you can see that the workflow I loaded is V4. This is my fourth version working on this, trying to get all the different steps correct. I will have this JSON file in the description, so there'll be a link to download it through Buy Me a Coffee for free, and patrons on Patreon will get it for free as well. They actually got it early. So download that, install it. If you don't want to do that, no problem. You can follow along anyway, or you can create your own list here. So super handy. And now I'm going to load my image. And this was already pre-processed or pre-stacked using the Nastronomy OSC pre-processing script. I'm not going to press play on that one. I'll show you what that looks like because I'm working on a couple of enhancements for this. It's pretty straightforward, and in the processing, I didn't got to fix that. That's why it's not public yet, but it is working really well, and this is what was used to stack this. So I'm just going to click that, check the checkbox to make say that this was already completed. And the next thing to do would be to auto stretch and crop. So we're going to auto stretch here within the viewer. I'll turn off linked stretch, and then I'll do a crop. So I'll just select this area here. If you watched my PixInsight video, I mentioned that I tried doing a large mosaic, which I failed because I only got 81 or 82 minutes of data instead of like the 6 or 7 hours that I had planned. Thanks to the weather. So I can zoom in, you can see just where the signal to noise ratio just changes drastically. It's because there's barely any data here. But anyways, I have this set. I'm gonna right click, crop. Let's fill that in, and then we can press check. This image here, if you're using your own, it's always good practice to plate solve. This image here, that if you're using my data set, it'll already be plate solved, but it's still a good practice to plate solve it because especially here when we cropped, the center of this image changed, so the RA and declination changed very slightly. All right, that plate solved. Kind of just covering the console here, but it's okay. Once this is done, we'll do SPCC. So we'll do image processing, color calibration, spectrophotometric color calibration. I was using an OSC sensor here with a UV IR cut filter. It's the IMX571 sensor. Pick your sensor, and the filter for me was UV IR cut filter. Nothing too special, and then I'll click on OK. So I got the two white balance summary charts here. So now our stars are well aligned. So I'll check that box. So the next two steps, these are kind of bundled. So I did starnet dash slash Psycon starlist. So you can use either of these to remove the stars. I am going to use starnet plus plus is because Psycon, I think, does some denoising and it messes with some of the data. So I'm not going to use that. I'm going to use starnet plus plus. Super simple. I'm going to image processing, starnet, star removal. Make sure pre-stretched linear image is selected. It does a little bit better with the stars. And generate star mask because we'll need it later. Click execute. All right, bye-bye stars. So now I'm going to check both of these because I'm not going to do Psycon starless. The next thing is stretching. So there's just going to be, you can do stretching whichever way you want. I put stretching using generalized hyperbolic stretch or the hypermetric stretch from Verilux. For this kind of data, I really prefer using GHS because it's a slow stretch and it lets me control a lot of it. And you'll see exactly what I mean when I stretch. But if you want to use Verilux, please go right ahead. So I'm going to go to image processing, stretches. I'm going to do generalized hyperbolic stretch. I want to uncheck the on top so that I can put my GHS window here. Move my shark here. And now I'm going to do some really slow stretches. So I'm going to switch it from auto stretch to linear. So if you see that it doesn't completely go dark, close GHS and then reopen GHS. It seems to be, I don't know if it's a bug, but you can see, there you go. See, it disappears and now it looks like I'm expecting. The first thing we're going to do is I'm going to go to black point or the linear stretch and move this over so that I have more room to work with when I'm stretching. And keep an eye on the clip here. You don't want to clip the data. Click on apply. So now we have our linear line here, our histogram here. So I'm going to go back to generalized hyperbolic transform. I'm not going to speed through any of this because people have mentioned to me that I should just show the whole thing. So there we go. So I'm trying to get it to like here, a little bit here. I think there was some like background sky there. So create a little box there and then click on the symmetry point here. And you can see something start to appear and click on apply. I'm going to go back to black point here, the linear stretch, and then move the histogram to the left again. Again, watching my clip. Click apply, generalized hyperbolic stretch. Now let's see, the histogram is getting fatter. Look at that. It's starting to come out of the water. Localize intensity, make sure the symmetry point is set. One thing I like about this is that it keeps the box here, so I can just keep clicking this. I'll do highlight protection a little bit. It'll help with like these little sprite areas here. Click apply and do the linear stretch one more time. Again, making sure I'm not clipping anything. There we go. Generalized hyperbolic stretch. Make sure I set my symmetry point. And then local intensity. And I'm going to move my symmetry point a little bit just to smooth out the histogram here, because otherwise it gets a little bumpy. Zooming out a little bit so I can see a little bit better. Okay. And the amount you do this will be dependent on your data, what you're looking at, what your preferences are. So I'm just really just eyeballing this, just making sure that my histogram looks okay. I do see some green here, so I'll definitely be doing some SCNR to get rid of that green. Decrease the highlights, it'll help me with some of the bright areas here. Click apply. And I think this will be it because you can see that the histogram is touching the left part. So if I do any more linear stretches, anything I do will start clipping data. A little bit of clipping is perfectly fine. So now I can check these off because I did not do HMS. Next we have noise removal. So you can use Graxpert or Psycon, that script. I'm not going to use Psycon, I'm going to use Graxpert AI. And it's going to be the first script I run through here because it's the only one I'm using. That's not a Siril process. I'm going to do denoising if you zoom in, you can see there's quite a bit of noise here, right? And I'm going to be pretty aggressive with this because this is already stretched data, and click on apply. All right, that finished. So I'll close this. You can see the before and after. Look at that. Now the shark is starting to pop more, right? You can see so much definition here. And again, this was 82 minutes of data from Bortle 3. And if you're wondering like why I didn't do a background extraction here or a like gradient correction, because I didn't have any gradients here. So that could be something that you may want to do with your image if you're using different data that's not mine. It would probably go before or maybe after you do Starlist, so you can extract the background there. So something to think about there. But if you watch my PixInsight video, I didn't do a background extraction there either. All right, noise removal is done, and then optional second stretch, I put that here because sometimes when I do Graxpert, it makes it darker than I want it to be. And what I usually do is I'll go to image processing, go to stretches, and go to generalized hyperbolic stretch and see where my histogram is. And it looks like I have a lot of room to work with, and I can stretch this quite a bit more. So what I'll do is go to linear stretch, reset my black point, and then go back to generalized hyperbolic. I still have my symmetry point, so I'll just click apply, and then let's stretch it out a little bit more. Again, this is going to be like personal preferences, right? Because you can definitely overcook your image if you do this too much. So that's why I said this is optional, so you don't have to do it. I have had mixed results, so this is my third time running through this data today. The first time it looked ugly, second time it looked kind of good, so that's why I left it. I'm going to do it a third time and see how it looks. Okay, I think this is good. And click on apply, and that's all. We have sufficient dark background. We do have some more noise popping out, but I think that's okay. But we're getting some nebulosity here. We'll try and control that in upcoming steps. Okay, let's bring this up. So we did the optional stretch, and now we have curves. So you can either do the regular curves through image processing, stretches, curves transformation, or you can do Verilux curves, which I'm actually going to do because it has one feature that I really, really like, and I wish Siril had that, which is masking. And the first thing I'm going to do is I'm just going to do like a quick S-curve here. Okay, just a very quick S-curve just to give me some contrast to work with. Click on apply. And then now we're going to enable masking. So we're going to do the range limiting and then click show mask. And then set the luminance to like something here. So because I want to affect just the nebulosity and not the background stars, I'm also going to bring down the max luminance because of the super bright regions. I don't want to affect those too much. And bring down the feather as well. So this is going to be more of a hard edit. So click on show mask to hide the mask, and then now we can play with these. One thing to know here is that this output here isn't full resolution. So if you start seeing it look weird, it's just a preview here. You can ignore that. Okay. I think that's good. Click on apply. One thing I wish this did was when I click on apply, it didn't reset this. So if I wanted to run this again, I would have to click this again so you can see it resets. Otherwise, it doesn't really apply. Okay. Got that. Show mask. Okay, click apply. And do the same thing for lightness here. Yeah, like 28 to 30% is I think where things are good for me. You can see that the nebula is starting to glow a little bit, right? It's starting to pop. Apply. And now I'm going to do a little bit of the color saturation. Again, applying the same range limiting because I don't want the background to start getting chroma. But I will increase the feather here, show mask, and then this is not going to be an S-curve, it's just going to be like a straight up. There we go. Click apply and then process. All right, there we go. So we can go back and forth. Again, there's some noise here. So I'm gonna check this, and look at that. Additional noise removal. Let's run Graxpert again. So I'm just gonna run it from this here. And again, I'm gonna be a little bit aggro. Click apply. All right, that worked, and it looks a wee bit better, I think. Look at the noise. Yeah, so it's a little bit smoother. Again, trick is to not overcook it. And yeah, like the stars that got removed, they stayed on as little dots. So StarNet didn't do the best job here, but for my testing, Cycon also didn't do that great of a job with this. So StarNet at least didn't denoise and remove noise that I didn't want removed. So anyways, okay, click on this. Next thing we can do is some contrast adjustment. You can use Clahe. It's going to be under filters, contrast limited, adaptive histogram, equalization. I'm just trying to like increase like some of the contrast here, but also not overcook again. Like this is overcooking. There we go. That's good enough. Play with it. And then I added one thing that says save, because when I start to do the merge stars using star recomposition, it closes this. It doesn't save it automatically. So click on save so that it saves. Did that. So there, I do see some green here. It's a little like stacking weird artifacts. So I'm going to do something that some people really like, which is image processing. Remove green noise, also known as SCNR. And then click on apply. There you go. The green goes away. Yay. Did I kill the green? Somewhat, but not bad, right? There wasn't a lot of green there anyway. All right, so that's good. And now we're going to merge the stars back in. Like I said, save. I did that already. So two ways to save. Two ways to merge in the stars. You can do Verilux Star Composer, or I've been sticking a lot with Siril processes. So I'm going to do image processing, star processing, and then star recomposition using Siril's thing. So it says close current image. Yes. I'm going to open the starless here as the background stretch. So there we go. And the star parameters here using this one, star mask. So I'm going to uncheck this so that I can move this here. All right, once we have things loaded, I'm going to zoom in a little bit just so we can see the stars come in here as I stretch this. So the left side would affect the nebula itself, which we don't really need to do because it's already stretched. And the right side here is for the stars themselves. You can kind of see the little artifacts here. So this is doing an async or async stretch. We can see the stars start to come in here. You can do a slow stretch here if you want. Click apply. And let's bring it back up. And what I'm trying to do is I'm trying to be careful so that the stars come in evenly and they don't create like weird artifacts around the little noisy areas that's been left behind by StarNet. And I'll zoom in a little bit, like yeah, like the halo here. It's really hard to control. Like this bundle of stars. This is the fault of StarNet for not being able to remove all of that. Same thing with the eyes of the shark. You can see there's a star here and there's supposed to be a star here. So I didn't do the best job of removing that. So I don't see the separation here. That's my only thing about this process here. Maybe I could have gotten better control using the Verilux Star Composer. I did try it for version 1. It gave me similar results. So I decided to skip it and stick with the native Siril process. Click apply. I think right now, like in the way this is, it looks really nice. What do you think? And of course you can stretch the shark a little bit more if you want to make it pop a little bit. So this is just a kind of like a GHS stretch. All right, then apply and close. All right, so this is our final product. You can do some more processing on this if you want, such as more contrast adjustments here, do another curves adjustments with the stars blended in. But you can see this looks really nice, right? The nebulosity around the Dark Shark Nebula. This actually looks better than what I got in PixInsight, the one that's getting printed. And in fact, I can show that to you by minimizing it because it's my background. You can see the Dark Shark Nebula looks more isolated from my PixInsight version, but I spent a lot of time here. The nebula looks good, and you can see the separation in the eyes of the Dark Shark Nebula taken out of here. Star Exterminator and PixInsight did a much better job of removing the stars here. And the stars also look really good in both of them. Now that we're done, I'm going to check these off, and now everything is completed. Hooray! And I will clear completed and share the JSON with you so you can follow along. And again, huge kudos to Rich from Deep Space Astro for this neat little script launcher script. If you enjoyed the video, I hope I earned your subscription and a like to this video. If you'd like to support me and the work that I do, please consider joining these wonderful people on Patreon, Buy Me a Coffee, and here on YouTube. I am eternally grateful. As I mentioned, the total work time for this version of Dark Shark Nebula was about 30 minutes from start to end. Also, as mentioned, I am way better at processing astro images in PixInsight than I am in Siril. And even if you don't have PixInsight, I would recommend checking out my PixInsight videos, because even if you don't have it, it's a really great way to learn concepts and workflow steps to see if you can adopt something from a PixInsight workflow and bring it into Siril, or if you use like AstroPixel Processor or a Deep Sky Stacker or anything. And if there's something there that I showed on the PixInsight version that I didn't show here and you're curious about it, let me know in the comments below, ask a question, and I will be more than happy to answer. And while you're at it, also check out my stacking scripts. I have two of them. There is one for smart telescopes and one for OSC. I'm working on updates to both of them, and I am always looking for feedback and always looking for people who want to test these scripts. So reach out to me on Discord, on social media, and check out those videos to learn how you can use those scripts. As always, thank you for watching, and until next time, clear skies.